The first quantum number we discussed is the shell. The second quantum number we discussed is the subshell. The next quantum number describes what are known as orbitals. Orbitals are the space where an electron has a high probability of being found. Orbital values depend on the subshell, and there are a specific number of orbitals allowed in each subshell. Each orbital can accommodate up to 2 electrons. Let's review the allowed number of orbitals in each subshell. The S subshell always has 1 orbital. This orbital looks like a sphere. P subshells always have 3 orbitals. These orbitals look like peanuts. D subshells always have 5 orbitals. These are usually shaped like a double peanut. And F subshells always have 7 orbitals. I use the term flower to describe them. Here are the general shapes and number of orbitals in each subshell. The S subshell always has 1 orbital that is spherical in shape. This sphere represents where electrons are most likely to be found. The P subshell always has 3 orbitals, which are shaped like peanuts. These orbitals are oriented 90 degrees from one another. Consider that the nucleus is at the origin of this coordinate system. The px orbital aligns along the x-axis, the pz aligns along the z-axis, and the py aligns along the y-axis, which is coming out of the screen. Mathematicians tend to have the y-axis as the vertical axis, but for some reason chemists have the z-axis as the vertical axis. You will be expected to sketch S and P orbitals. The D subshell always has 5 orbitals. Most of these have 4 lobes, which is why I call them double peanuts. The F subshell has 7 orbitals. These orbitals have multiple lobes, which is why I call them flowers.